Welcome to Section 3.2, 3 ways to prove triangles congruent. Our objective is to identify included angles and sides and apply the side-side-side, side-angle-side, and angle-side-angle postulates. Our class and homework is going to be on page 120 to 124, numbers 1 through 3, 16 to 19, 23, and 25 to 26. So the first thing we have to talk about is the word included. What does it mean to be included? Well, to me, being included means that it's smack dab in the middle, kind of like a Chips Ahoy cream witch. It's smack dab in the middle. Now, more mathematically speaking, angles and sides that are included are adjacent to two angles or sides, whatever it's not. So in other words, if we have an included angle, it's smashed in between two sides. If we have an included side, it's smashed between two angles. Now, what I want to do is I want to name the side that's included by angle G and angle J. So here we go. Let's trace over angle G, and let's trace over angle J. The side that's actually smashed or included in those angles is going to be the side where we see the overlap. It's going to be side GJ is the included side. Alright, so next, we're going to name the angle that is included by HG and by HJ. So here we go. HG, HJ. The angle that's included or smashed in the middle is going to be this angle here where the intersection happens. It's going to be angle H. It's going to be our included angle. It's smack dab in the middle. Now, our next ones, I want you to try on your own. I want you to figure out which sides include angle G. So what two sides do we need to have in order to smash angle G? The second question, which two angles do we need to include side GH? Press pause and let's make sure we can do this. So here we go. Angle G is this angle right here. If we want the two sides that are going to smash this angle right here, my two sides are going to be side HG and side GJ. Now that second one, the angles that are going to include side GH. Side GH is this side right here. So I want to know which angles are going to have to smash it. So which angles are going to have that overlap? There's going to be one angle, and here's going to be a second angle. Those two angles have the overlap on that segment. So we have angle H and angle G are going to be the angles that include side GH. So now we start to talk about our postulates. Our first postulate is the side-side-side postulate, or SSS for short. And here's what it reads. If there exists a correspondence between the vertices of two triangles such that the three sides of one triangle are congruent to the corresponding sides of the other triangle, the two triangles are congruent. Now that's a mouthful. Let's actually draw this out and see what we're looking at. So the picture that would actually match with this, we're going to have our two triangles. We need to have a correspondence between the three sides of one triangle and three sides of another triangle, which means that we're going to have matches. This would be one set of congruent sides, here would be our second set, and here would be our third set. All three don't have to be congruent to each other, but we have to have three sets of matches in order to have triangles congruent by the SSS postulate. Now you might be thinking to yourself, the last section we were doing, we needed to have all the sides and all the angles. The postulates that we're doing today, we only are going to use 3 pieces. These are shortcuts for proving triangles congruent. Here's our second postulate, or our second shortcut for proving triangles congruent. It's the side-angle-side postulate, or SAS for short. And here we go. If there exists a correspondence between the vertices of two triangles such that two sides in the included angle of one triangle are congruent to the corresponding parts of the other triangle, the two triangles are congruent by SAS. So let's go ahead and draw that picture out. Now, for this, it's important that we are using the included angle. So it has to be the angle that's smashed in the middle of our corresponding sides. So let's match some of these up. And I'm going to rotate my figure so that it doesn't look the same. Here's one pair of congruent sides. Here's the second pair of congruent sides. Now the angle that's smashed in the middle, well, let's look at it. There's one side. Here's the other side. So here would be my angle smashed in the middle. Here's one side. Here's my other side. So here's my angle smashed in the middle. With these pieces of congruency, we would have our triangles congruent by side, angle, side. So here's our last postulate, the angle, side angle postulate, or ASA for short. If there exists a correspondence between the vertices of two triangles such that two angles on the included side of one triangle are congruent to the corresponding parts of the other triangle, the two triangles are congruent by ASA. Let's see if you can draw out this picture. Press pause and let's see what we come up with. So here's the picture that I have. I got my two triangles, and now I need to have two congruent angles and an included side. So I'm going to start with my angles. 1, 2, 1, 2. You can put your angles anywhere, but we have to have two matches. Now, my included side is the side smashed in the middle. So it would be this side here and this side here. As long as we have these pieces of congruency, we can state that our triangles are congruent by angle, side angle. So here's some examples. For our first set of examples, we want to know what additional information would be needed to prove the triangles are congruent. Two different ways. So the first thing that we have is we have side, side, side. Now for side, 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 we need to have three congruent sides. Here's one side, here's two sides, and they have matches. What we need here is we need that third side. So what I would still need in order to prove congruency would be side BC congruent to side EF. And then I would have my side, side, side. I'd have my three congruent sides. Now, for our next one, we're going to use these same triangles with the same tick marks already given. And we want to know what would be needed if we were going to prove the triangles congruent by side, angle, side. Notice the A is smashed between the two S's. And that's where we want our angle. We want it included. We want it smashed in the middle. So here's my two sides. My angle that's smashed in the middle is going to be this angle right here, angle A. On this triangle, my angle is going to be angle D. It's smashed in the middle. We would need to have angle A also congruent to angle D to prove the triangle is congruent by side, angle, side. So now we got a couple for you to try. We have what additional piece of information would be needed to prove the triangles are congruent by angle, side, angle, and side, angle, side. If you think you know where to go, press pause. If not, I'm going to give you a hint. So here's my hint. All we have is one piece of congruency. And on my last picture, I'm going to flip back. We were given two pieces of congruency. Now, we only want to know an additional piece, so one single piece. What do I know by looking at my picture? What's going on here? Well, hopefully we're seeing those bow tie vertical angles. That's not something that needs to be stated. That's something we already know. So now, we have our two pieces of information, one that's given to us and one that we can determine on our own. What else would still be needed for angle, side, angle, and then side, angle, side? Let's see what you can come up with. For angle, side, angle, we want our side smashed between our two angles. Well, I have my side and I have one angle. I need the other angle that would smash it. The other angle that would smash it would be angle W and angle Z. We would need to know angle W is congruent to angle Z in order to prove my triangle is congruent by angle, side, angle. Now, my next one. What would I need to prove for side, angle, side? For side, angle, side, we need the angle smushed between the two sides. We got a side, we got an angle. We need the other side that's going to smush that angle. The other side that would include that angle is going to be side YV and side XV. If YV was congruent to XV, we would have triangles congruent by side, angle, side. Alright, before we start our proofs, here we go, a little bit more. Name the congruent triangles and the justification for the congruency. So what we're going to do here is we're going to write a congruency statement, and we're going to state why they're congruent based on the picture. Now, I look at my two triangles that I have. I have two side congruencies and one angle congruency. The angle is an included angle. It's smashed in between the two sides. So my triangles would be congruent by side, angle, side. Now we have to be careful. Just like yesterday, when we write our congruency statement, we want to have correspondence of letters. My first triangle I'm going to call triangle HIJ. My second triangle I got to be careful with. We have to look at all these pieces. We have angle H. When I look at angle H is made with a side with a 1 tick mark and a side with no tick mark. Which angle has that on my other triangle? Here's my 1 tick mark side. Here's my no tick mark side. The angle is going to be right here at angle M. That should be my first letter. My second letter is angle I. I had a right angle, so L should also be my second letter. My last one left was angle J. Over here, the only one left that I have is angle K. I want to double check angle K. So here we go. Angle J was made with a side with a 2 tick mark and a side with no tick mark. The side with a 2 tick mark and a no tick mark is K, and perfect. They match up. Now let's look at the second picture. I want you to determine first and foremost what tick marks can we put in without needing to know it. Hopefully you said we have a reflexive side. We don't have to be given that. We can automatically deduce that based on properties that we know. Now, when I look at this, I have two sides in an angle. But there's a problem. That angle is not included. Now, here's what we're going to do. We're going to think, does the side angle side property apply here? No, it doesn't. For side angle side, the angle has to be included or it's being smashed in the middle, which would be this angle NPO and this angle NPQ. What does this spell out? Well, I'm going to spell it out backwards. It's side-side angle. And trust me, I know what that says, and it's not a nice word. We don't use naughty words in math class, so we're not going to use naughty words in proofs either. What we're going to have to say here is no triangles are congruent. We don't have enough information. So if it's not going to work out for us, it's not going to work out for us. Don't force something that's not there. Now, the moment you've all been waiting for, our proofs. Yay! Here we go. We got our statements and our reasons. Make sure you're always copying down these drawings. It's important for us to always draw in our tick marks so we actually see what type of congruency we have going on here. So here we go. Let's start with these givens. We have AD is congruent to CD. The reason is going to be given. Our second one, B is the midpoint of AC. That information is also going to be given. Now, anytime you state congruency, we draw a congruency. AD is congruent to CD. B is the midpoint. We can't put any tick marks, but let's go ahead and let's use our keyword of midpoint. We know what a midpoint does. It divides a segment into two congruent segments. So let's go ahead. AB is congruent to BC. We're using that keyword's definition. So definition of a midpoint is going to be our reason. We said congruency, let's draw congruency. Now, I got 2 out of 3 pieces of information, and when I look at my figure, I see that I have a reflexive side. DB on my left triangle is congruent to DB on my right triangle. They're the same segment. It's the reflexive property. I said congruency, I draw congruency, and I look at what I have. I have 3 congruent sides on one triangle, 3 congruent sides on the other triangle. So let's go ahead and state our congruency. Triangle ABD is congruent to triangle CBD by the side-side-side postulate. Easy peasy lemon squeezy, right? Now it's your turn. So we're given our picture. We're given 2 givens. We want to prove triangle BOW is congruent to triangle ITW. Press pause and let's see what we can do. So here we go. We have TO bisects BI, that's given to us, and angle B is congruent to angle I. That's also going to be given. Anytime we say congruency, we draw congruency, so here we go. So next, if TO is bisecting BI, BI is the segment that's being chopped in half. So it's going to be cut into 2 congruent pieces. BW is congruent to WI by definition of a bisector. We stated congruency, let's draw it in. And now I look at my picture, and I see I have bow tie angles. Bow tie angles are formed from intersecting lines forming vertical angles. Let's state those vertical angles. Angle BWO is congruent to angle TWI. The reason? Vertical angles are congruent. I look at my picture and I see 3 pieces of congruency, 2 angles and a side. So I ask myself, is that side included between those angles? And it is. It's smashed in the middle. So we can go ahead and state our triangle congruency. Triangle BOW is congruent to triangle ITW by angle, side angle. And we're set. Now hopefully this lesson wasn't too painful for us, because this is just the beginning of our triangle proofs. Here's the answers to our homework. If you have any questions, please make sure you make note of it, and make sure you ask me tomorrow. And as always, have a good one.